All right, this is the beginning of 10-3. This section is the area of circles. Hence the ton of circles on the page, just for fun. All right, so you're going to need a pencil, colors, so colorful pens, and paper in order to take notes. Pause the video and get those materials. Press play when you're ready to go. All right, so you should, by the end of this lesson, be able to find the area of circles, as well as find the area of irregular figures that include parts of circles. So let's get started. If you were to draw a nice big circle on your paper, and if you were to mark about the center of that circle, you could use a compass to draw your circle if you want it to be really straight. Sorry, not straight. If you want it to be really perfect circular. And then you can use a ruler and you can draw lines going across your circle. If you were to cut your circle into a bunch of little wedges, like I'm doing, if you cut equal size wedges, you could take and you could put those wedges and you could eventually make a rectangle out of those. There we go. This end is kind of messed up. But you could make a circle out of these wedges. This is kind of a rough drawing, but it shows that eventually those circles could form a circle. And you could actually use this area, you know the area of a rectangle equals base times height, right? Your base length times your height. And you can use that area of a parallelogram or a rectangle, and you can actually find the area of a circle. Because we know that the height here of this rectangle is equal to my radius. So I can substitute that in. I can say, I'm going to change colors here. My area equals my base times, and in the place of height, here, I'm going to put that this is the radius of my circle. So times r, because this h is equal to the radius. All right, so see how we're going there? Now I know that my base, the length of this base here, is about half the circumference. It's about 1/2 the circumference of my circle. If I were to go around my circle, this base is about half my circumference. Because, if you notice here, every other top is kind of like every other piece of this circle here is being measured. So let's ignore these up here. I'm counting 1, 2, 3, 4, 5, 6. But over here, in order for those 6 to show on my base here, I'm actually counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over here. So 12 around my circle equals 6 on my base. It's about 1/2 my circumference, or the outside area of my circle. So when I write my area formula for a circle, it's area equals And in the place of B, in place of my base, I'm going to put 1/2 C times R. So the area of a circumference, the area of a circle is 1/2 C times R. And we know that circumference equals 2 pi r. We learned that in chapter 9. So we can substitute this in. We can take what we know here and put it in the place of C. So we can rewrite our formula that area equals 1/2 times 2 pi r times r. Okay, that becomes, if we simplify, area equals, this 2 cancels out here, so it's pi r, and there's 2 r's right here, so that's pi r squared. So let's rewrite that. The area of our circle, the area, I have an issue spelling here. The area of a circle is 1/2, is what we just came up with, pi r squared. All right, so that's the formula for a circle. So we're going to go about and we're going to use that information. This is a formula you're going to need to know. We're going to practice writing again and again today. And we can express the exact area of a circle by using the term pi here. If we use the term 3.14 in the place of pi, then it's an estimate. Pi is exact, okay? So if you leave it in terms of pi, you have an exact answer. If you use like 3.14, you have an estimate answer. So we're going to go ahead and we're going to do an example. So example 1, let's practice using our area formula that we just discovered. So if you want to find the exact area of a circle with a diameter of 12 centimeters. That's our given information. All right, so we can go ahead and do this by saying, I'm going to draw a circle. And if I know that the diameter here is 12 centimeters, I know the relationship between the diameter and the radius. The radius equals 1/2 the diameter. So I can find my radius by saying radius equals 1/2 times 12, so equals 6 centimeters. All right, so area formula equals pi r squared. So I'm going to plug in what I know. I know area equals pi times, I just found the area, the radius. So pi 6 squared. So area equals 36 pi centimeters squared. We have to remember our units still. Okay, this right here is your final answer because it says to find an exact area, so we leave it in terms of pi. All right, I'm going to have you do an example. Your job, example 1A, is to find the exact area of a circle with a radius of 50 inches. Go ahead and plug that in. Pause the video when you're ready to see the answer, hit play. Okay, so you should have found that your area equals 2,500 pi inches squared. You would have written out, you should have as your work, area equals pi r squared. All you have to do is plug that in. So area equals pi, you know your radius, right? Radius of 50, you plug that in for r. So 50 squared, and you multiply that out. So when you multiply out 50, you get 2,500. That's 50 squared. And so you know area equals 2,500 pi inches squared. Because we're finding an exact area again. So we leave it in terms of pi. All right, so let's go on and we're going to do another example. And we're going to find an approximate value. Because for real life situations, you usually want an approximate area as opposed to a precise exact area, because it doesn't really matter in a lot of cases. All right, so in our example, this is example 2. It's a real world application. It's kind of like, why would we be studying the area of circles, right? Why does it matter to us? Well, so okay, let's say that the size of a mountain lion territory is depends on how much food is available. When there's lots of food, the circle around, say this is the mountain lion's home, the circle around the mountain lion's home doesn't need to be very large. However, when the food is scarce, that circular territory might expand out. We might now have a radius of a larger size, right? So your radius expands as scarcity of food increases. When there's lots of food, this radius might be about 5 miles diameter. So we're going to find the area of a region if there's a lot of food. How far out would the line be moving? So we're going to plug in. We know area equals pi r squared. We're going to say, okay, we know the. Sorry, that doesn't make any sense. Radius equals 5-inch diameter. Let's rephrase that. The circle for available food if there's lots of available food, it's a 5-meter diameter. Sorry, not 5 meter, 5 mile diameter. They're going to move out even farther than that if food is more scarce. So area equals pi r squared. We're going to plug in what we know. So area equals pi times 5 squared. So the area equals, we want to find, since this is the real world, and you know that mountain lions don't, they're not going to be moving exactly 5 miles out. It might be a little more, it might be a little less. So we're going to do an approximate. This is just a range that they might move. Area equals pi 5 squared, so that's area equals, wait, hold on, I caught a mistake. Then we are given the diameter, right? Well, the radius equals 1/2 the diameter. So the radius would equal 1/2 times 5, so equals 2.5. So we're going to plug in 2.5 here. So 2.5 squared is actually 6.225. We're going to do pi. So that means the area equals, we can plug in, we can say 6.25. We'll times that by pi. So we're going to actually type in 1.34 in our calculators and find out what the answer is. We're going to get an approximate amount. So there would be approximately 9.625 miles squared. So that means lions hunt about 20 miles squared. Hunt an area of about 20 miles squared. So that means that the actual territory of a mountain lion probably ranges from like maybe 15 to 25 miles. Right, we're just taking a guesstimate. So we can have an approximate symbol there to show that we are estimating. We are using an imprecise number. It's not exact. And in real life, that's completely true. You're not going to have a real life. You're not going to actually need, a precise circular map. You're going to want an approximate. Go ahead. I want you to find the area of a circle with a radius of 6 miles. I want you to find the approximate area. Pause the video, go ahead and do that. Alright, welcome back. So you should have found that area equals 113 miles squared by plugging in area equals pi r squared. So the area equals pi, they give you a radius, so you don't have to times a half. So you just plug in 6 squared, so area equals 36 times pi, so that's 113 miles. Miles squared. Alright, we're going to move forward now to finding the area of irregular figures. Alright, so irregular figures, you might have, say, shape like this. Say this is a field, and we need to figure out how many seeds that we're going to scatter, right? If, say, I'm going to list our given information. Our question, grass, it's okay, given information. Grass seeds come in 3-pound bags. 1 bag covers 675 feet squared. This field that we want to seed is 45 feet long. It's 45 feet long by 25 feet long here. This distance right here is 30 feet. All right, you need to find how many bags of seed that you're gonna need to cover the area of this whole field. We want to seed the entire field. Okay, so how many bags of seed would it take to cover this entire field? Well, there isn't an area formula that would quite cover what we're shown here. But I can go ahead and I can take this given information and say, I have a rectangle and I have a half circle. So I'm going to go ahead and separate those figures. So for the rectangle, I was given that I have 45 feet by 25 feet. And I know that the area of a rectangle is base times height. So I'm going to plug that in. So my area is 45 times 25. So my area is 1,125 feet squared. Okay, so that's this rectangle here. I also have that little half circle, right? And this distance here was 30 feet. Well, I know that the area of a circle is pi r squared. So if I have a half circle, that means my area is going to be 1/2 times my pi r squared. 1/2 my area of a whole circle, right? Well, this 30 here is a diameter. So that equals d. And my radius I know is 1/2 times my diameter, so I can say radius equals 1/2 times 30. So my radius equals 15 feet. So I'm going to plug that in. So if I know my area equals 1/2 for this half circle times pi r squared, so times pi, my radius is 15. So I'm going to say my area equals 15 squared is 225, so 1/2 times pi times 225. And this is an exact area I want to find because I'm covering an exact amount of space. So I'm going to leave it in terms of pi for now. So my area equals 1/2 times 225. That is 112.5 pi feet squared. Okay, so I'm going to take this, what I just found, my area of my half circle. I'm going to go back and look over here, and I'm going to take this area of my rectangle. So 111.25 plus, so the area of the rectangle plus the area of the half circle equals the whole area. So the area of my half circle is 112.5 pi. Actually, in order to be able to add them, I need to multiply out this pi because this side doesn't have pi. So I'm going to multiply out my 112 times 3.14. So I have 1125 plus, I'm going to multiply by 3.14 plus 353.25. All right, let's add them together. I now have 1,478.25. So that is my area. Okay, let's look back at our target question. Now that I have my area, our target question was the number of bags of seeds. And we are given that the grass seeds are sold in 3-pound bags, and one bag covers 375 square feet. So we can take and we can say, this is our total area. Let's write this again on another page. Let's say 1478.25 equals our area. And our area total. And one bag covers 675 feet squared. This is feet squared. Okay, so I'm going to divide my 1478.25 divided by 675 in order to get the number of bags. Because my feet squared will cancel out and I'll be left with, it's 675 feet squared per bag. So feet squared are going to cancel out, be left with the number of bags. So my final answer is the number of bags equals 2.19. Okay, I can't buy a partial bag, so that means I'm going to need to round up. So my final answer is the number of bags needed is 3 bags. Normally with 2.19, you would round down, right? You would say it's about 2.2. I'm going to round that down to about 2. But in this case, you wouldn't have enough seed if you didn't have above 2.19. So we're going to round up. We're going to say our final answer, number of bags needed is 3 pounds. All right, your homework for tonight, let's go over first. In class assignment, you're going to do on page 515, numbers 7, 10, 12, and 17, as well as number 26. All right, your homework is 10-3 practice book page. Okay? Ask any questions if you feel like you don't understand something, but you should be getting started on these practice problems now.